So let's hear from Shay Rojansky, Principal Software Engineer working on .NET Data Access and Performance, member of the Entity Framework team at Microsoft. Have you ever asked yourself how Entity Framework Core does its magic translating your LINQ queries all the way to SQL and reading the results back as .NET objects? In this talk, we will dive deep into the EF pipeline and discuss the challenges, the architecture, and the solution to some complex problems. We will discuss performance, SQL optimization, code generation, LINQ expression trees, null semantics headaches, and the various fascinating low-level details that you have thought about when interacting with EF as a user.
Thank you very much. Let me start a timer here so I get stressed if I talk too much, which will certainly happen. So, hi everybody. Thank you for waking up early. An 8:30 talk and seeing all these attendees is actually, it's very impressive, so thanks a lot. Two very logistical things. If I start to move in this direction, everybody should lift their hands or shout at me because I'm supposed to stay in this area, but I'm notoriously moving around all the time, and plus we have a cable here, so I'm really going to try to stay in this area. How many people here actually know EF Core or use EF Core in some regular capacity? Okay, most people. That's a good thing. So I have an idea of the basic level. So just a few words about myself. We'll dive pretty quickly into the subject, but I do want to talk 2 seconds. So I work for Microsoft. I'm part of the .NET Data Access team. Most of what I do in my day-to-day is EF Core, but it's not the only thing. Especially nowadays, there's vector databases for anybody. Anybody using vector databases already? Just curious. Okay, just a little bit. So if you're going to be doing AI, there's a chance you might, go into this area. I worked a lot on designing a .NET abstraction for accessing vector databases. I'm also very involved in anything related to Postgres. So if you're doing Postgres on .NET, if you're doing databases, I hope you're doing Postgres because obviously it's the best database. So if you're doing Postgres on .NET, there's a very good chance you're using my software. So I rewrote like the low-level driver. I also maintain the EF Core provider for Postgres. So I'm very much this intersection between .NET and Postgres. That's my thing. That was always my thing. I love perf quite a lot. I worked with Seb also on perf quite a lot on the .NET side. Perf in databases means sometimes different things, right? Like it's less important to maybe profile and remove an allocation or like a little thing. What's much more important is, of course, to generate good SQL, to do less round trips to the database. So performance is always like an interesting thing, and that's a thing that I love. I'm a Linux guy originally. I grew up in an anti-Microsoft guy. I hated Microsoft back in the 90s, and I was Linux and all that kind of stuff, which is a bit embarrassing for me now, or whatever, but I mean, it is what it is. I am on Mac right now, but at least it's a sort of a Unix-like system. That's what I'm telling myself. Hopefully, I'm going to be back in Linux at some point. I'm based in Berlin as well, but that's kind of irrelevant. Like the .NET team and my team is completely spread out geographically. So enough about me. I want to just give a brief overview of what this talk is about. So this is this is a useless talk. It's useless in the sense that this doesn't tell you how to use EF Core in a better way. It doesn't explain how to get the most out of EF Core or anything like this. It's really a deep dive inside what an ORM looks like, and in that sense, it's useless to users. Of course, that's not really true. I think a lot of people agree that you need to know what is the complexity and what's happening under the hood, right? It's always good to understand the kind of complexity that's going on so that you can avoid certain things, and in general, it's interesting, and we're here because we're curious people and engineers and so on. So I've kind of structured this talk around the idea of caching inside EF Core, so it's a perf talk as well, but caching is kind of just a sort of a way for us to go through a very interesting set of problems that we have inside EF Core when we translate LINQ to SQL. So it's caching, but also not really caching. Another main point of this is to understand how EF Core as an ORM is not quite the same as other ORMs. There's different kinds of ORMs. You guys use another ORM if you're using Orchard. I'm not very familiar with SQL. It will be interesting to maybe think about a comparison there. But if I compare to traditional ORMs in other platforms, then things look quite different in EF Core, and that's a thing I want people to kind of know and understand. Am I standing okay physically? Am I still? Yeah, very good, awesome. So just to be very, very let's first like this, like just to set a very simple baseline. I think everybody here knows what LINQ is, but it's worth repeating. There's a very interesting feature in C#, which is a bit unique among languages. C# has something that's technically sometimes called quotation. Probably you haven't heard this word so much, but basically the where that you see here is not the same where that you use when you're using the normal enumerable where, right? I guess you guys know this. The lambda that you see here doesn't actually get executed or evaluated, right? We don't have a list here that we go over in C# and .NET and filter. Instead, what happens is that this code gets passed as an expression tree into the ORM, and the ORM is responsible for translating that thing into SQL or to any other thing. That's called a quotation because this code here looks like C# code, and it is C# code, but it doesn't get executed as .NET at all. This capability is actually a little bit rare. Like if you go to various other languages, depends which one, you won't necessarily have it. As far as I know, last time I checked, for example, in Java, there's simply no, it's a language level feature. The compiler has to support something like this in order to do it, right? And .NET has it. It's an amazing feature of LINQ, but many other languages don't have it. And the whole concept of querying in EF Core is that it's a LINQ provider, right? So we use C# to express what we want to query, how we want to query, and then it's somebody else's job to actually translate that into SQL. In most other ORMs, there's many kinds, but in many other ORMs, what you usually have, this is an example from Juke, which is a very well-known, very good Java ORM, very mainstream. What you usually will see is a DSL approach. So basically, you use Java to express SQL. So you have concepts like select from, where, and order by, which are really SQL keywords, right? You use Java to, so this is strongly typed, so at least you have a strongly typed thing. You're not writing magic strings with SQL, which will fail if you have a typo, so it is strongly typed, but you're still expressing yourself in SQL. So you as the programmer have the task of thinking about what you want to do in terms of SQL, and then you're expressing it as SQL. You're just using Java to express it, but it's a DSL, whereas here, you're not thinking in SQL at all, you're thinking in C#. That's basically a main difference between what EF Core does or what LINQ providers do or LINQ-based ORMs do and various other things. So that's just to set the baseline, and we'll explore what this means, like this difference quite a lot in this talk. So I'm going to jump in, and we're going to start right away talking about caching. So now we're going inside EF Core, inside what's called the query pipeline of EF Core, so the thing that translates from LINQ eventually to SQL. At a very, very high level, like this is not yet going into any internals, it's just to set like basic concepts. Our input into EF Core, now we're inside the ORM, is a LINQ query tree. We'll see what that looks like in a second, right? But it's some sort of representation. It's going to be a bit like an abstract syntax tree. How many people here, by the way, have dealt with abstract syntax tree in some? Maybe in university even or something like this. Okay, there's some sort of familiarity, but it's quite rare. Usually you don't need to do this unless you're building a compiler, or EF is sort of a compiler, by the way. Like we think of it as a transpiler. It compiles from one high-level language to another high-level language, so less a compiler, more a transpiler, but doesn't matter. Abstract syntax trees are very cool. It's very fun to work with them, but it's rare and kind of complicated. So we've got an input, which is a representation of code, in this case of a LINQ query, right? And then we have something which we really do call compilation. Again, we think of ourselves as a compiler, so we are going to take this thing and we're going to pass it through a series of visitors and pipelines and transformations, where the input is going to be this LINQ query tree, and the output is going to be two things. One, everybody knows, is of course the SQL that we're going to send to the database. That's our obvious kind of thing. But there's another thing that people usually don't think about. An ORM's job is also to materialize the results, to hydrate the results, whatever term you want to use, as your .NET objects, right? As your POCOs. That's part of what the ORM does, right? The data coming back from the database is just a table, right? It's relational table kind of data. We still need to hydrate it. So what EF Core does is it generates something that we call a shaper or a materializer, which is a piece of code for this query that knows how to read the results from DB data reader, from the low-level ADO.NET reader API, and materialize your customer or blog or whatever it is that you're mapping to the database. So the shaper or materializer, a bit less obvious, people don't think about it, is generated at runtime by EF Core in order to efficiently materialize the results of this specific query that we're compiling right now. And anybody who, I just said, generated at runtime, so obviously this is a big problem for native AOT, and that's a thing that we're thinking about, how to get around and how to make EF Core native AOT compatible. Anybody here use native AOT? And how many people here care about native AOT? I'm just doing a quick That's nice to see that there's some, okay. Anyway, so that's just our general kind of, there's inputs and there's outputs. Now, what does a query tree look like? I do want to spend 2 seconds on this. So if we focus on something like this, we have context blocks where, that's the thing that LINQ query that we saw. So what EF Core sees as input is a LINQ expression tree. If you look in system LINQ expressions, that's a namespace in .NET. It's a built-in namespace. You will see all kinds of stuff. You'll see nodes, basically, types that represent nodes. And what we have here is a node of type method call expression that represents an invocation or a call of a method. It points to the reflection method info for where, because that's the method that we're calling here. The left side is not so interesting. It represents the table, let's call it. But what's more interesting is on the right-hand side, I'm doing a little bit of simplification here, but inside there's a lambda and so on, and inside there's something called a binary expression of type greater than. So that represents this operator, and it has a left and a right. That's what they look like. That's really what it looks like. It's a binary, so it has 2 operands. On the left-hand side, we have a member expression. That kind of corresponds to the dot here, where the member itself is ID, and then before the dot, we have a parameter expression. But of course, instead of having b.id, we could have an arbitrary big expression in C# with invocations and things and whatever, and that would replace this node here with some subtree that could be arbitrarily complex. So expression trees can be very, very big and nested, and treating them is very, very recursive. It's very interesting. It's like a completely different kind of programming when you have to deal with it. But anyway, that's not the point here. On the right-hand side, we have a constant inside the lambda, right? It's not a variable. This is important in a few slides. So that's called a constant expression because it's a literal, really inside that thing. It could be something else, but right now we actually literally have a constant with that value. So that's the input that we get in EF Core. Now remember, we're supposed to be talking about caching here, right? So if we recap, the idea here is that compilation is long and we don't want to have to do it every single time that the query is executed, right? This same code, if we do it in a loop, or we call it every single time again and again, we don't want to be compiling it every single time. So how do we achieve this? The answer is almost always when you have a perf problem, introduce caching, right? Like that's almost always what you do. I'm kind of joking, but not completely, like joking, not joking. So if we do want to introduce caching here, then what we need is a cache key, first of all, right? So what is the cache key in a situation like this? It's an unusual sort of cache key. The cache key is, in fact, the incoming expression tree, all of the entire tree, right? So the moment we have, like this is a simplified representation of that tree. So we've got this query. The first time that we see it, we'll do the whole compilation and we'll cache the SQL and everything. And then the next time we have an incoming query, we're going to have to recursively make sure that the nodes correspond, right? If there's any difference in between this tree and that tree, then we have to have a cache miss. For example, if we now have a query that's the same in every way except that here, instead of a 3, we have a 4, we can't reuse the SQL because the SQL contains 3 and not 4. Or if instead of ID we compare some other property like name or age or something like that, we have to fail this thing. We have to have a cache miss, right? So it's a heavy cache key. Is that a question?
Does it mean that you use the reference of the AST as the key in a dictionary? And you have a custom.
It's not a reference because every single time every single time the query is executed, we get a new instance of a tree. It's not like the same tree that we get in from the compiler. We really get like different instances of the nodes. We have to actually go across the tree, calculate a hash code, and then also do an equality. So do a recursive equality around each of the nodes. This is actually not very light. It's like performance-wise not very...
That's my question. So you have to create your own hash code to navigate.
Exactly. We have an expression tree comparer which implements hash code and equality for expression trees. I don't think it's very efficient at the moment, by the way. There's a lot of potential for improvement there. Like we compute the hash code like by going through the entire tree where we probably don't have to do that. We're doing a lot of processing that probably could be optimized there. But the problem is there. Right? We need to do something like this because our input is complete trees that are different in terms of the instances. They're different each time. That's our input. We can't control that in EF Core or any LINQ provider, basically. So I hope that's kind of clear. That would be our cache key, right? And this would be our outputs. Like again, to push home what Seb was kind of trying to get at, usually when you have a cache, the key is something like one string, or maybe an int. It's a simple value, right? Here we have a very complex sort of cache key, and it's not trivial to think how to basically do this efficiently, right? But anyway, Remember that this is also an ORM, so we're going to be sending a query to the database. There's going to be networking involved. There's a lot of, if it's anything beyond a trivial query, there's processing and disk I/O at the database. So this is kind of going to be dominated, right? It's going to be drowned out in terms of the overall processing that needs to be done when you execute a database query, but we're still very perf conscious. All right, so we're gradually going to be making this diagram more and more complex and adding more boxes and things, right? You'll get this. So now we have something called a query cache here, where the incoming LINQ query tree, when the query cache is empty, we have to compile, and then we get the shaper and the SQL, but these are now cached based on the cache key. And the next time we get the exact same query, we can jump over this whole thing and we have a cache, right? Very basic stuff. So let's start making this a bit complicated. What I've done here is I've taken the 3 out to a local variable. If you look at this from just you're a C# developer, we've done nothing, right? The code does exactly the same thing. It's literally the same code, right? Except it's not really the same code, right? Anybody who knows a little bit about C# internals knows that we've actually created a closure, right? This is called a captured variable. We've captured a local variable. We've lifted it up to a closure. Basically, in C#, this has nothing to do with LINQ or EF. Basically, this thing, because it references this variable, we don't know when this, where this lambda is going to go. Maybe it will get evaluated after this whole function actually exits. And so this can't be a local variable on the stack anymore because the stack might have been unwound, right? We might have exited the function and there's no more local variable by the time that this thing actually gets loaded, right? So we have to lift it up to the heap. That's basically what a closure does with a captured variable. That's all that is the C# side of it. But in EF, we've also done a very, very important architectural design decision. We've basically made the decision that a captured variable like this is your way, the user's way of telling us that you want this to be parameterized in SQL. That's a design decision, right? Basically, we're saying, which is this thing that you see here. So before we had a 3 here, so you had a 3 in the SQL. Now we have a variable here, a captured variable. So what you're seeing is a parameter placeholder in SQL. Okay? I hope that's kind of clear. That's a decision, right? We didn't have to build it this way, but it makes a lot of sense. Why? Because the point here, the moment that this is a captured variable coming from somewhere else, that means that this same query is going to be executed with different values, right? Sometimes it's going to be 3, sometimes it's going to be 4, which corresponds very well. We flow this notion all the way into the SQL. It corresponds very well with the idea that we have a single SQL. Just like we have a single LINQ query here, we've got a single SQL where there's a placeholder that's going to vary each and every time. But if you integrate the 3 right into here, you're telling us this is never going to vary because it just doesn't, right? It's in there, so we're going to put it in there into the SQL as well. So we kind of align a weird C# feature called captured variables and closures to something that's completely SQL database related, which is parameter placeholders, okay? Seb is going to be annoying, I know, in this talk. I can feel it already.
I thought you were saying that you were always complaining about asking questions.
No,
okay?
I just like the presentation.
And if you do that, it's just because you want to cache the same expression, right?
So inside EF, this allows us to cache the same expression. We'll just see in 2 seconds how we do this. But the more important even thing, that's very important, but the even more important thing is that we want to be able to use a parameter placeholder in the SQL. That's the main thing that we want to do. Okay, why do we want to use parameters in SQL?
But if you didn't use a parameter, you would have as many queries in the cache as you have values. That you use.
Yes.
That's why I'm saying maybe it just matters in terms of reusing the same statement and be able to vary the value.
So what you're saying is true at 2 levels. That's what I'm trying to say. For one thing, inside EF, yes, we want all of these invocations to use a single cache entry inside EF, right? That's one thing, because compilation is long, and we don't want this to get compiled every single time. The ID value is different. At the same time, we want the exact same effect inside SQL Server and Postgres, right? Because, so that's basic. I'm answering the question that I just asked. That's actually the more important thing, what I'm saying now. Databases, if you put a parameter placeholder, they plan for this SQL exactly once, right? They see that there's a parameter here, they plan for this query, and they cache that plan as well. In SQL Server, they cache it server-side. In NPG SQL and Postgres, it works a bit different. It's the driver that does the caching and uses prepared statements in the database. It doesn't matter. The important thing is that at the database side, let's say, there's a single prepared statement or a cached plan, which means that the next time that we run this thing, it's not just EF that's more efficient, it's also the database that's more efficient because it doesn't have to parse the SQL, it doesn't have to plan how it's going to actually execute it, which indexes it's going to use based on the statistics in the table, which join strategy it's going to use when joining, all that kind of stuff. That's the reason that you want to parameterize your queries in SQL, regardless of EF, regardless of anything, is because this is about performance. This is about making your SQL run faster. Another reason to parameterize is to avoid SQL injection, but at least when using, that was your question? Okay. Anyway, like sometimes when I talk about placeholders and SQL parameters, people say, yeah, SQL injection. That's absolutely true. Like that's a good answer. But at least when EF core is producing the SQL, there's no danger of SQL injection because EF already escapes all of your, for example, if instead of, if I go back to, so I'm spending a lot of time on this, but it seems kind of important. If instead of a 3 here, we had a string, we said something equals a string, a literal string here, then as I said, here you would not have a parameter placeholder, you would have an actual string in SQL. Of course, we protect you against SQL injection in that case, EF, right? You can put whatever you want in that string. We will, like if you put a single quote, we will escape it by duplicating it, right? So the moment you're using EF Core's LINQ APIs, you're safe from SQL injection regardless of parameters. That's kind of what I'm trying to say. But parameters are still very important for performance. That's the point here. Okay, and this is, so anybody doing SQL, this is super important, really, really super important for getting your queries to run efficiently. But that's creating problems. Now I'm getting back kind of more to the talk. That creates problems for our caching mechanism, right? So just like we want to allow the plans to be cached at the database because it's the same SQL, the same, really, literally the same SQL, we also want it to stay cached inside EF. And the mechanism that we've just said up to now is not sufficient. Why? Because if you look at the query, at the incoming expression tree with the captured variable, remember here we had a constant expression, right? Now we no longer have a constant expression when you see ID. What you have here is a really nice representation of the closure. Remember, this is really a closure in terms of how the C# compiler looks at it. What we have here is an actual member expression over a constant that points to the closure object. So this thing is going to be an actual instance of a compiler-generated type that has been lifted, that contains your local, what should have been a local variable, is now a member on this internal type. It has a name. If you actually inspect this, if you're curious and you look behind the scenes what is looking on, you decompile this, you look at the IL, you'll see that there's a type here called _ display class something something. Maybe you guys know this. There's some special characters in there. So there's the compiler really generates a specific type to hold all the local variables that have been captured in this code. That's simply how it works. And then the LINQ expression tree actually represents that thing. This is why you see a member expression here, although there is no dot in the LINQ expression here, right? I hope that's all kind of clear. We're diving into the internals. Anyway, so the problem here is this, because the closure object that you see here will be different every single time. That's also related to your question from before. Every time you run that function, basically the C# code, the .NET code, instantiates a new instance of the closure internal type to hold the local variables, right? It's a different instance every time. And if we naively compare our caching, the cache keys, we will always have a cache miss because of this thing. And we will always end up recompiling the entire query just because there's a parameter in there. Is this making sense up to now? It's not too bad, right? Cool. So then what do we do? How do we go around this? How do we still maintain a caching story around parameterization is the question here. The answer is not that difficult, right? What we want to do is extract those parameters out. We do a pass before the cache lookup, and wherever we see this sort of pattern of a closure, what we want to do is we're going to replace it with a custom expression node that I made up called query parameter expression. This is really how it's called inside EF Core. So we put in a placeholder. We basically do the same placeholder that you see in SQL conceptually. We put in a placeholder. It has the name, but what it doesn't have is the value. So all we know is that here there's a parameter called ID. And this kind of represents what the actual C# code looks like, right? There was just an ID there. We didn't see all that crap with closures and captured variables. Of course, we still have to lift out the actual value somewhere because we'll need to send it to the database at some point, right? But it's not part of the query tree anymore. It's in some other place. That's very important. We put it somewhere else and we forget about it for now. So that the tree has now been kind of sanitized. We punched holes inside the tree wherever there was a parameter, and we put placeholders in there so that, there's many reasons why we do it, but so that we can compare trees and get cache hits. Okay, now the trees can be equal when we do this, right? So I've added a box here that is called parameter extraction. The actual component in EF is called the funcletizer. That's a very advanced, fancy name, but it doesn't really matter. The primary function here is to extract parameters out of the tree. This has to happen before the query cache lookup, so that we can get a cache hit. Everything making sense so far? Awesome. Okay, let's make it even more complex. So now I'm going to do a detour. I'm going to do a detour. This is not going to seem relevant in any way to this talk, but it will be very relevant very soon. So quick test. If we want to translate, like we're translating LINQ to SQL, this is now completely different. We're shifting gears. Let's say we want all the customers whose first name is equal to their last name. Okay? So the naive translation here would be where first name equals last name. Where is this wrong? Any ideas?
No.
Not said. Not said. Not said.
Maybe I'm wrong.
Okay, sir.
How do you compare strings?
That's a
collations and
awesome answer. Awesome answer. That's very true, and I'm about to say this. You're right. But before this, because the title of the section is nulls. Anybody have an idea? I'll make my question. It's a bit of a trick question. How will this behave differently than this? Is the real question here.
Casing server-side on single server for clusters.
That's what he said. Basically, the collation, the uppercase, lowercase, absolutely true, completely true, but just not what I'm.
Don't compare nulls in the database and in C# the same way.
Exactly. That's what I'm.
There is equal and there is if.
That's exactly right. So this will fail. It will not behave in the same way for customers where the first name and the last name is null. In C#, this returns true, right? Because null equals null is true. In SQL, this does not return true. It returns null. Okay, so if first name and last name is null, then the result of this expression is null. It always amazes me how few people actually really understand this. So I will actually do a quick overview of three-value logic. Yeah.
If Matt Storgensen was rewriting SQL, he would add new expression, new operators to compare values. Is not null or value.
Give me 5 seconds. give me 2 seconds, you'll see this. So technically, what I'm talking about here, like if we want to be a bit academic, C# and most languages that you know are languages that are called two-value logic. It means that you have two possible answers, true and false, right, in your logic.
It has 5 or 7.
JavaScript is not really a language, so I'm not really including it. It's something else. Exactly. So I'll exclude it from the discussion. SQL.
We are web developers. We don't like you anymore.
Sorry, I made myself hated. That's true. Excuse me. JavaScript is awesome. Anyway, SQL is a three-value logic because instead of having just true and false, you have true, false, and null. That's basically and it's worth actually saying, I have a slide just to explain this concept. So in SQL, null is not a value like in C#. In C# or Java or all those normal languages, which does not include JavaScript, null is just another value. A string can be foo, it can be bar, it can be null, and you compare them and it works the same way, right? In SQL, null is actually unknown. It means we're missing that. I'm going to say it like this. It's not very formal, but it means we're missing that data. Like when we were looking for the customer's names, that guy wasn't home. So we know there's a customer there. We just don't know what his name is, right? That's the way to think about SQL null. It really helps. This is why when you ask if null is equals null, you're basically saying if something that I don't know is equal to another thing that I don't know, the only answer to that question can be we don't know. It actually could be true when we go and find out the first and the last names. Maybe they are equal, in fact, but we don't know that right now. So the answer cannot be false and it cannot be true. It can only be I don't know. It's basically a logic that allows you to say I have no idea what the answer is. That's how SQL works, and it's particularly well adapted for data retrieval, for databases. There's a reason why, like it actually makes a lot of sense. Like if you want to ask, give me all the customers older than 70, okay, you get all the customers who are known to be older than 70. And then if you ask, give me all the customers who are less or equal to 70, you get all those who are known to be less or equal to 70. But there's a third group of customers where we don't know what their age is. So it's really 3 groups, right? The logic splits your data into 3 groups and not into 2, as usual, as you're used to, right? To be completely clear, one last thing that I wanted to say. So it's worth mentioning that if you find null in the context of a where clause, so if you do where null, okay, like we basically just did here, this is where null, then the behavior of SQL is to evaluate null to false. This is why we sometimes use the term falsy. Falsy in SQL is false or null because they behave the same in where, but not in other contexts. Null is not the same as false in other contexts. Yeah.
So SQL is a proper language?
It is a very proper language. It's just a very strange language. JavaScript is not a language. SQL is a weird language. Repeat after me. Just to be... Just to make, do people know what a truth table is? Has people seen this in university? So truth table is very easy. So true and, this is the truth table for and in 2-value logic in C#. So true and true is true, true and false is false. Basically everything is false except for true and true. And here everything is true except for false or false, right? Because it's enough for one of the sides to be true for the entire expression to be true. Now let's do this exercise on SQL, 3-value logic language. If you do, so of course, true and false, this part of the table is the same, of course. It would be a bit nuts if it weren't. But if you do true and null, you get null, because it might be true or it might be false depending on that thing that we don't know. But if you do false and null, you get back false, because we already have enough information from the left side to know that the entire expression is going to be false. Make sense? Same thing with or. If you do true or null, you get true because we don't really care what's behind that null. We don't know it, but it doesn't change the output of the expression, right? But anyway, you get the idea, right? This is how 3-value logic works. And in EF Core, we've made the decision, this is again a very strong architectural decision, that users writing C# expect us to translate that to SQL that will have the same semantics around null. So when you write when first name equals last name, you expect to get customers where both of these are null. We could have decided to not do that. That's really a decision. But since users are now writing C#, we assume that they want the SQL to behave like the C# they write. And here you see where our job is starting to get very complicated because of LINQ. Because users express queries via C# and not via SQL or a DSL, right? We've taken on a huge responsibility. Okay, so what EF Core is, among other things, is a translator from 2-value logic to 3-value logic. That's a formal sort of definition of what EF does. And to do that, to preserve C# meaning, the translation is going to be where last name is equal to first name, or first name is null and last name is null. This is what we mean when we say that EF compensates for the difference between 2-value and 3-value logic. I hope that's kind of clear. Of course, this has a perf cost, like to do this extra kind of compensation. So if one of these is non-nullable, like if one of the columns is non-nullable, we can skip it, right? We can go back to the nice terse translation, and we do that. We do exactly this sort of optimization. But we can't do it if the expression is negated. And this I'm going to leave as an expression to the reader. Think about this at home. Like if this whole thing is not equals instead of equals, then something else happens. But we don't have enough time to think about this.
Was there any consideration to handle this more with compiler warnings and stuff like that? Like telling you, be aware that this might not yield the results you want.
So the problem is that practically everything you write will have some sort of warning. So it's not great if we did this. Instead, we said we'll take care of it for you. We'll actually take care of it. EF does have a very obscure feature where you can tell us don't do relational null semantics. Basically, that's what it's called. Sorry, don't do C# null semantics, do relational null semantics, and that means don't do any of this crap, all of this compensation. What I write, just translate to SQL more directly. It's people get very confused by this because, again, they're writing C#. And they expect it to work like C#, right? And nobody uses this. Basically, everybody relies on this. We've also been talking about equality, but think that we actually have to do this for every single expression type to maintain semantics. This is a big job. This is actually a lot of complexity inside EF core, unfortunately. Now, like just taking this forward, I'm probably not going to be able to complete everything I have in this talk, but it's okay. All the questions are actually very cool. I'm just going to really quickly, if we do the same thing and extract a parameter out, then again, we have a problem. Like the naive translation would be something like this, right? But once again, this doesn't work when the parameter is null. You can't say where name equals null. That doesn't work. The result of that will always be null, right? When you ask is this equals to I don't know, the answer will always be I don't know, because we don't know, right? That's the whole point. This is why SQL has a special way to check for nulls. Now you're maybe starting to understand why SQL has a special way to check for nulls. Like that's part of the three-value logic nature of the language. So we would have, that's actually a little bit wrong. I forgot something here. So we would have to say where name equals at name, or at name is null and name is null. Like I forgot, I left out a bit of the clause here. But this is enough of a common scenario where all this extra SQL is really quite bad for perf. It would hurt our indexed usage. And it's so basic that we wanted to do better. So what we actually want to produce is this SQL for when the parameter is null, and another SQL for when it's not null. I hope that's kind of clear. I'm going a little bit fast. In other words, what we want to do is to produce two SQLs for the same LINQ query, based on whether the parameter is null or not, because the null or not distinction makes everything different because of this three-value logic problem, right? So we're again complicating our story because we no longer have a one-to-one mapping from LINQ queries to SQL. We now have a single LINQ query with two SQLs, right? So how do we manage this situation? We again have to make things a bit more complicated. So I'm again evolving the query pipeline to make it more like what EF core actually looks like. We're starting to get very near to what EF core actually looks like inside. So first of all, what you see here, I've replaced the SQL with something called an intermediate SQL tree. So this is no longer a string. It's an intermediate expression tree that represents the SQL query. It's already been translated, but it's not finalized yet. There's still some stuff to be done because of all these nulls. Very importantly, I'm drawing a wall here. Up to this point, above this line, none of compilation, none of this process has any access to the parameters that have been extracted in this phase. That's very important. Remember we extracted the parameters, we put them in a box somewhere else, and we forgot about them. If there's any access from compilation to that box, then the output of this compilation will be invalid, because it would be different based on the parameter, right? We would not be able to cache that thing. We have to be oblivious of the parameter values while we are doing the compilation, otherwise we can't cache. So we have this wall of blindness to parameter data. We only know that there's a parameter, we don't know what it is. Is it 3? Is it 4? Is it null? But after we finish this stage, we now have a second part of the query pipeline, which has another cache called the SQL cache. The SQL cache this is a little bit tricky, but it's not that bad. Basically, we have another stage that is able to look at the nullness of the parameters. This is where we're going to be able to finally look at the parameter and ask, is it null or not, and make changes in the SQL to accommodate for that fact. So this is where we look at the parameter and we say, oh, if it's null, we actually put in the SQL tree is null. And if it's not null, then we'll put equals and the parameter placeholder. This is where we split our LINQ query into 2 or even 4. N. Yeah, exactly. It's 2 to the power of nullable parameters. That's the number that's the potential variations of SQLs that will get generated from a LINQ query. Okay? Yeah, it's quite interesting. And all of these get cached here as well, because even this processing, which is quite small, we don't want to be doing it every single time. So we put a cache here. Now, what is the key for that cache? So if the point here is to vary based on the nullness of parameters, then the cache key is going to be basically some sort of bit array, like a bitmap that tells me, for P, is it null or not, 1 or 0? For Q, is it null or not? Basically, the combined nullness of all the parameters in the query is the query cache for this second layer cache. Okay, I've kind of dropped a bit of a bomb there, but hopefully this is still making sense. We basically want to be able to produce variants of SQL, right, for the same query based on the nullness of the parameters. That's the point, just because we need that in order to produce efficient SQL that runs well on databases. Okay? I hope that's kind of making sense. Think about how this whole thing is managed if you have to write your own SQL or use something like Juke to express SQL via a like if you need to express the SQL via a DSL, you need to be thinking about these things yourself. You need to be aware of the difference between I'm doing an is-null check or I'm doing a comparison check or what. You need to know SQL and code in that way as well. Whereas EF-Core is kind of taking care of this. You look confused, Sam. Juke is the ORM that I showed in the very beginning, the Java ORM where I showed a code fragment from it. It's just basically an example of another ORM that doesn't use LINQ. Instead, you use a DSL to express SQL, right? Just try to compare in your head what all this looks like without EF-Core. That's kind of what I'm trying to tell you. Okay, let's see how much time I have. Okay, I'm actually I think I'm going to do this last section because it's super cool. It also allows me to talk about a big fail of mine, which I always kind of like to do. So this one is actually going to be relevant for EF10. This is an actual user-facing part of this talk, finally. It's not just internals, which is kind of cool. So here's another complicated problem in SQL. Let's say you have this LINQ query where you do new123 contains BID. Very, very, very typical. By the way, this very, very syntax has been just broken by C#14. That's exactly the one that we were talking about before. And we had to compensate for this in EF-Core, and Seb also had to compensate for it in SQL, if I'm not mistaken. Anyway, that's not the topic here. This very simple construct that everybody uses all the time, it's basically a way to get all the rows where the ID is 1, 2, or 3, right? It's a shorthand for ORs. It's a more efficient way, more condensed way to write a lot of ORs, right? Fine. So it's very easy. SQL happens to have a very nice construct, even nicer than the C# way, right? Which is the in expression. I hope maybe one day we get in C# as well. That would be super cool. But in the meantime, we use this kind of thing. So you can translate this exactly the same way. It's a one-to-one mapping. Finally, there's like a simple mapping. We just inverse the order, right? Like here, the array comes first and then the element, and here it's the opposite. But otherwise, it's a mathematically nice kind of translation. Unless you think about nulls, but let's not. So, but again, I'm going to do the same thing I'm doing like this whole talk. I'm extracting something out, and it's no longer inside. Instead, it's a local variable. It's a closure, right? So what happens when I do this? Now, I told you that when we have a captured variable, we want to parameterize. But databases in general don't have a concept of an array. You can't send SQL Server an array. There's no such thing as an array in relational databases, right? SQL doesn't know about array. SQL knows about row sets or unordered sets of rows, right? They're unordered, so it's already not the same as an array, and it's rows, it's not scalars. There's no such idea of an array of scalars. Postgres does have a notion of an array, like a first-class notion of array, and it's really, really cool, but it's the only database almost. Oracle also has a thing, but SQL Server, for example, does not. I don't know how many people are aware of this. Anyway, so we have this problem. How do we translate this? And this is where I get to a fail story. This is where you should be interested because we really kind of messed up in EF-Core around this question. So in EF-Core before 8, we basically we didn't have any choice, we thought, and so on. So we inlined this thing as constant. So the SQL that you see is the same as if this was inside the LINQ query, as if it was not a closure, okay? Which violates the principle that I said before. When you take something out of the query, it becomes a parameter placeholder, right? So why is this bad? It works, it's fine. But it produces a completely different SQL every time I run this query with different array elements, right? So then we get different SQLs, which means that SQL Server has to, or whatever database you're using, has to recompile this every single time and go through all of the planning. This is very heavy. Really, in database programming, this is really, really quite bad. What's even worse, SQL Server caches those plans by default. Not by default, always caches those plans. Which means that if you're running this query a lot with different array parameters, you're caching a huge amount of SQLs, which you will likely never use again, right? There's a huge cardinality, there's a huge variance here that will bloat your SQL Server plan cache, will maybe evict other SQLs which are actually important, and you're filling up your cache with crap, basically, right? And this was kind of bad enough that This perf problem was the most highly voted issue on the EF core repo for a while, for quite a while actually, right? So people were telling us, please fix this, please do something better for us. And this is where I get to my fail. When I was working on EF8, this is also when relational databases started getting really, really good with JSON. All relation databases now have very good JSON support, right? They're competing with NoSQL databases, document databases that are JSON-oriented. All databases now allow you to have a JSON column, and inside you have a JSON document. You can query inside it. Like Mongo, like Cosmos, you can do this in Postgres and SQL Server as well. And in fact, in SQL Server, if you do want to have an array of ints today, or an array of strings, the way to do that without putting it in another table with a foreign key relationship, you basically use a JSON array. JSON arrays are kind of the substitute for an array type now in most relational databases, and it works. And in EF Core 8, you can have an array of strings on your entity type, and we will map that to a JSON column, and it works fine. You can even filter by it. You can do everything. It really works nicely. So because we did all of this thing, I also thought that this would be a great answer to this problem. I basically reasoned, and I think it was very elegant, but it was wrong. Basically, it's really nice when something is elegant but wrong at the same time. So basically we said, okay, if the natural representation of an array, an int array, is a JSON array, so what we'll do is we'll just pack this IDs into a JSON array as a string, and we'll send it as a parameter to SQL Server. And then SQL Server has a mechanism for taking a JSON array and parsing it into a row set, into like a table, like a temporary table. And this is first-class supported things. This is not a hack or anything. This is like a very, very documented, well-regarded way of doing things. So OpenJSON takes this IDs and opens it up into a relational row set, like a table. And at that point, I can use just the normal SQL mechanics. Basically, I have an in with a subquery. And the subquery comes from my string parameter. So I pack the array into a string representing an array. I send it over to SQL Server where it's unpacked, and then we use in to compare against it. This is not the same in as before. The in that we had before had just a set of values, and here we have a subquery. I'm just saying. But it's conceptually the same thing. So it's super elegant. It solved the problem, and we have exactly one SQL no matter what is contained in the array, right? If we vary the array here, int 123, 124, 125, we still have the exact same SQL, and the only thing that changes is the parameter. So we've reached exactly what we wanted in the beginning, right? Which is to not vary the SQL, and SQL Server can cache the plan, and we don't have the bloat. The problem is solved. I was very proud of myself. Except when databases plan for how to execute queries, they construct their plans. One of the very important things is the cardinality of tables, right? When you join between different things, different tables, for example, SQL Server, your database will look how many elements how many rows there are actually in a database, and it will choose, for example, its join strategy based on this. I don't know how many of you know, but databases can perform, when you do join, SQL is declarative. It says what to do. It doesn't say how to do anything, right? So when you say join in SQL, a database could be using a hash join strategy. It could be using a merge join strategy. There are various strategies that it could be using, and the decision on that will be based on how many rows there are in each table. The cardinality of your data plays a very important role in doing effective query planning in the database. That's kind of what I'm trying to say. And by doing this, what we just did here was to make the query planner blind to the cardinality of the collection. In this case, it probably doesn't matter much, okay? It's not going to affect the query very much. But in many cases, it does. And when we released EF Core 8, we started getting not many, but a few reports that a query that worked in 3 milliseconds before, in EF Core 7, started taking 3 seconds, like a 1,000-fold decrease in speed, because we've robbed the query planner of essential information, which is the cardinality, okay, by doing this JSON trick. So it's a really elegant solution, but unfortunately it doesn't really work. In EF9, we already gave you opt-out and opt-out of this and knobs to control when to do it and all kinds of things. But in EF10, we've actually moved to doing a different thing, which is a more standard sort of solution, a more traditional solution, and probably works better. We basically inline the array, but the values themselves are still parameterized. So it's a half and half kind of solution, okay? As long as the array has a size of 3, the SQL stays the same. I'll just finish the sentence, right? As long as the size is the same, we get to cache our queries. But the moment you put more elements into the array, then you're starting to get different SQL, and you have the problem of multiple SQLs. I'll finish the slide, then so to optimize this even further, we even do some padding. Dapper, by the way, if anybody knows and uses Dapper, Dapper does the same thing. We got inspired a little bit by Dapper. So we even pad, for example, you give us 3, maybe we'll add 2 more parameters here, which duplicate the value of the last one. It doesn't change the semantics of in. We'll just basically add 2 more parameters just so that the SQL is the same, just to reduce the number of variants of SQL, so that instead of having a variant for each cardinality of the array, we have buckets of variants. Yeah? Yeah.
My question was from the last slide that you answered in this slide, that was about what would Dapper do?
This is what Dapper does. Yeah. This is exactly it, and it's one of those problems. I hate this with all my soul. This is one of those problems where there's no correct solution. There's the one solution that if we just spend a year and work, we'll implement it and we're done. There is no solution to this problem that fits all, like in some cases this is better, in other cases this is better. I hate it when that happens, especially in EF, which means the only thing we can do now is to allow you to, so we need to provide a reasonable default, the right thing that kind of works for people, and then give you knobs for the queries where it really matters. You can actually determine this now in EF Core. So we give you knobs to say, on a per query basis even, this, in this case, do this, do that. Like we really allow you to go into determine how the LINQ is translated to SQL, which is not ideal. We should be doing the translation to SQL in the optimal way, but there is no optimal way here. All right? I want to get to the end and leave some room for okay, we're kind of almost at the end. So I'll just give you one last idea around this. We really are at the end. The problem is that now what we have here is the SQL is varying again, if we go back to caching, based on the number of parameters in the array, right? But our cache that we said here only knows about the nullness of the keys. We built it originally only to do the nullness. So when you have a query that has such a contains over a parameterized collection, we actually disable the SQL cache altogether, because we don't have a mechanism for now to cache SQL based on the number of elements in an array, right? We might do this in the future. So, but for those queries, very specifically, we have a mechanism that says don't cache the SQL, and then this part of the query pipeline will run on every invocation. The good news is that this is really short. It's really like a couple of visitors. This is where all of the time is, especially producing the shaper materializer. There's a ton of heavy lifting here. This is really, really short. All right, so now this is really what the query pipeline looks like inside EF to handle nullability, all of that stuff. All I wanted to basically say here, like to kind of get you to understand this, because we have LINQ, and that means that users use C# to express their queries, we take on a huge amount of work. We are a much more high-level ORM than the usual ORM. We do all the work so that you don't have to think about nulls and the proper translation for parameterized collections and all that stuff and how to cache all the SQL. So we do a ton of work, which is very complicated, and that's why EF Core is probably one of the more complicated ORMs in existence. I hope that kind of gave you an idea of what we do and that you found it interesting as well. And I think I'll open it to questions now, yeah? Thank you for bearing with me. I took a bit more time. But by the way, there's a panel discussion in the afternoon where I'll also be if you want to, yeah.
Oh, thank you. That was really super interesting. I'm curious about whether there are equivalent frameworks, warrants, or better word, on other platforms like Java, or is there anything that compares even remotely?
I'm not aware of anything that goes this far. Again, especially other languages and platforms are many times constrained by their lack of quotations. They simply don't have a way for the user to write their normal language and have that be translated as an expression tree. So you just can't do it. It's like a very technical constraint that means you can't do it in many cases.
I was about to say Mongo has the same kind of structure, but it's a document DB, so it doesn't apply to SQL, but in terms of expressing the query.
No, absolutely. So Mongo have a LINQ provider in C#, by the way. They have their own LINQ provider, and they have an EF.
Made by previous CF core developers.
Correct. Yeah, correct. Exactly. And Arthur Vickers, by the way, now works at Mongo. And Damien Gard, exactly, yeah. And now they also have an EF provider on top of that LINQ provider. So they have anyway, you don't have to do EF, but in any case, but that's still C#, that's .NET. I don't think, as far as I know, if you want to use Mongo from Java, you don't have LINQ. You just don't have LINQ, basically, right? This, by the way, is, I'm just going to say, I think this is, it's stupid to say this, but this is really a place where .NET and C# really shine compared to other places. Like, it's very old. This is not like, I'm not telling you about a cool new thing. It's like, I don't know how long since LINQ was done. And still, this is something where I hear people moving from .NET to some other platform, and one of the things they miss the most is LINQ, and especially doing database stuff via LINQ. Like, this is a thing, it's always a pain when you have to like do database stuff inside your code with a DSL, with strings. It's always like a painful story.
Does he have do subqueries? And if yes, does he do the whole thing recursively or how do you?
So there's subqueries and then there's common table expressions. If you're thinking, so subqueries are actually very, very easy, but I don't have a whiteboard. Otherwise I would tell you, if, for example, if inside the where, instead of doing IDs contains, you would do something like C for the customer dot orders dot any. So if you put another LINQ query inside here, that's a subquery. We translate it into a subquery in SQL. And this works perfectly, like it really does work. So that's subquery, but you're also asking, I think, about recursive common table expressions, recursive CTEs. And this one, it's one of the things that I really want to do. I have an idea, I know more or less how I want to do it, but there hasn't been time to implement. But the nice thing is, when we do implement it, then anyway, I don't want to, maybe we'll talk about it later. It's one of the things I want to do.
Thank you. It was fascinating because first time to have a look at EF from the inside. First question, so the cache, is it an internal thing? So it cannot be distributed. So in case of distributed application, we can.
No. So yeah, we actually, EF is actually a very, has a dependency injection container inside, and everything is services inside. And the cache is actually, there's a service there, which by default, it's just an internal memory thing. And theoretically, you could also make it into a distributed cache. I don't think that makes a lot of sense for this kind of thing, personally. Like,
case of distributed APIs, so I don't have to recompile.
In theory, but this is not the kind of, so compilation is slow, but it's not slow, it's not like very slow, I'm gonna say, right? It's not like slow in the sense that you do a computation that lasts an hour. It takes, I don't know, a few, like 100 milliseconds, I don't know, I haven't measured it. So that's usually not a thing that you want to introduce distributed caching for. You just want to do it only the first time and not the next time. But right?
My next question is, when you have some tricky situation, for example, this recipe, have you thought about, for example, temporary functions in databases?
Temporary tables?
Functions.
Temporary functions, like create a function?
Yes, on the fly, and because it supports a lot of complex parameters.
So there are, first, I'm not exactly sure where it would solve a problem that I talked about here, to have a temporary function. I mean, I'm trying to think about it, but in any case, creating a function, creating things in the database, or a temporary table, by the way, is, by the way, a very heavy operation in general. It's more of a DDL-y kind of operation, and therefore, it's many, many times, like, for example, we had a thing where we created a temporary table automatically in order to do certain things. In EF7, I was looking at performance, I profiled various things, and I found that this is the source of huge performance issues. Removing a temporary table caused the EF's save changes to work much, much faster in SQL Server. That's one thing. And the other thing is, when you create a function, then how do you know if you've already created it? And how do you manage it? Like, then you need to drop it if it already exists. But all this, it creates a lot of problems. And EF is basically kind of like a stateless ORM, right? It doesn't know if it already created or did not. This creates a lot of complexity.
And my last question is, what's your strategy about backward compatibility with databases? So to which version have you support?
Like versions of SQL Server or so on? Yeah, so in general, like the policy or the idea is whatever database is supported by the vendor should be supported by EF as well. That's the idea. That's what I do with EF Core, with the EF Core provider for Postgres. So the CI for the Postgres provider of EF Core tests on all the supported Postgres versions. When Postgres 13 goes out of support, I go and I remove it from the CI, and that's it, and I'm done. And if somebody complains about something that's only a problem there, I say, I'm sorry, it's not supported. Yeah.
Thank you.
Thank you. Great presentation. What happened to the cache keys? Like, does it remain same and then get piled up or?
Yeah. So the cache, again, you can tweak this if you really want to go into the internals, but nobody does this. The default thing, there is a maximum cache size and an LRU, least recently used. So basically, it grows up to, if I remember correctly, 1,000, but I'm not sure. It's 1,000, but not 1,000 queries. Anyway, there's a reasonable amount. It grows and fills it up. When that is full, then the least recently used gets evicted. So that, of course, memory cannot grow infinitely, right?
So it happens by itself.
Sorry? Yeah, it happens by itself, yeah. We don't even implement the cache. We use the ASP.NET memory cache, if I remember correctly. Okay. Of course, no problem. Thank you very much.